Hi everyone. In this video, we are going to talk about object detection using Tensorflow.js. Tensorflow.js is a library used for training and deploying deep learning models in the browser. Let's look at how this works. We start off with opening the application on a browser. Here we are using Chrome on an Android device. The Start Webcam button starts the camera recording. Let's see if the model can detect this couch. The Take Snapshot button lets us capture a frame. Once we have a frame, we scroll down and click on Detect Objects.
Couch with probability 0.79.
This called the model, which detected the object and used text-to-speech to read out the objects found and the confidence of prediction.
Let's walk through the code. Here we have the HTML file for our application. But first, why do we need Tensorflow.js? Because there are no drivers and no installs. Data stays on the client side. It's interactive and can run on desktop or smartphone. The fun thing about Tensorflow.js is that we can 1. Train a model in the browser and run it in the browser. 2. Train a model offline and run it interactively in the browser. Or 3. Train a model offline and customize it in the browser. In the code, within the head tags, we set the metadata for our page and import our style sheet, Tensorflow.js library, and our pre-trained coco-ssd object detection model. SSD stands for Single Shot Multi-Box Detection. The model has been trained on the COCO dataset and is capable of detecting 90 classes of objects. It can take any browser-based image element as input. After that, we start building the web page. We define all our HTML and CSS elements for the application, create buttons for starting and stopping the webcam and taking a snapshot. Within the video tag, we define the aspects and dimensions of our camera stream. Below that, in the canvas tags, we create a placeholder that will contain our snapshot. Once we have all these pieces in place, we create a Detect Objects button which will load and call our model to detect objects in the snapshot. Inside the script tags, we have all our JavaScript elements. While defining constraints, we make sure we set the facing mode parameter to environment so that it uses the back camera of the cell phone. We define 3 functions which respond to our 3 interactive buttons. The print object function will return our model's predictions in a form that can be easily displayed on the web page. The text-to-speech function will take the predictions and read out the classes and their associated probabilities. It uses speech synthesis utterance, which is HTML5's inbuilt text-to-speech utility. The function drawBoxes takes the predictions, extracts the locations of the predicted objects in the image, and draws boxes on the snapshot. Along with that, it also writes the classes and probabilities of the detected objects near their bounding boxes. Finally, we have a clear function to clear out previous predictions every time a new image is captured. Now, let's look at the main function that does everything: detect objects. This function first fills the status placeholder and stores the snapshot in a variable called image. Then, the coco-ssd model is loaded and called to make predictions on this image. We get our predictions in form of an array of dictionaries with bounding boxes, classes, and probabilities. We then tie all this together by passing our predictions through drawboxes, filling our HTML placeholder to display the predictions, and then finally calling the text-to-speech function. As you can see, the entire application is a single HTML file and is less than 200 lines of code.
Now let's look at few more samples of the application. The model here detects the laptop as well as the persons on the screen. It can successfully detect multiple objects in any given image. And as with all good deep learning models, it does a great job at detecting cats. Let's look at a useful application for this in obstacle detection for the visually impaired. We could extend this app to do object detection in real time and identify obstacles in the field of view. The user points their smartphone at the environment, and the app identifies all objects in front of the user. It then uses text-to-speech to warn the user about potential obstacles.